multiplying rational expressions isn't really any more difficult than simplifying rational expressions. It's just more like a marathon than a sprint. The first thing I always need to do is make sure that I factor everybody. And in this case, I'm going to give you the methods of factoring that I would use, and then show you the factored form. In the top left, I would use a is not equal to 1. Bottom left, I would use GCF, which isn't too hard to pick out because there's no squared or quadratic term. Top right, I would use difference of squares because I have a binomial, that's a telltale sign. And in the bottom right, I'm going to use a equals 1 because of a being 1. So when I factor these, I get the following. In the top left, it becomes 2x plus 1 times x plus 3. The bottom, I pull out a 3, I get 3x minus 4. In the top right, difference of squares, again, becomes those conjugates, x plus 4, x minus 4. And the bottom right is going to factor into x plus 3 and x plus 5, because 3 and 5 multiply to 15 and add to 8. At this point, I stop and make sure that I complete step 2, which is my domain restrictions. So to find the domain restrictions, I look for those values that would make the denominators equal 0. And I have to look at every piece in a denominator that might equal 0, which is just those 3 right there. I don't have to worry about 3 because he's the number 3, and he's never going to be 0. So I can go through and just list off these domain restrictions. X is not going to be positive 4 from the first one, negative 3 from the second, and negative 5 from the third. Though they're not in order from least to greatest, those are going to be my 3 domain restrictions. So step 3, the last thing I need to do is reduce. I look for common terms, monomials and binomials, in top and bottom, and see what will reduce out. The only monomial I see is the 3, and he doesn't have any sort of number on top and bottom he can reduce with, so he's going to drop down eventually. I look for binomials that will reduce. The x minus 4s will reduce. The x plus 3s will reduce, because when I consider multiplication, it's like these are all on the same big fraction. So I can reduce in the numerator or denominator of each of the expressions, or any numerator and any denominator whatsoever. So when I drop down all my pieces, I get a 2x plus 1 and an x plus 4 in the numerator. And last but not least, I get a 3 and an x plus 5 in the denominator. That is my simplified rational expression after I've multiplied these two things together. And that, along with my domain restrictions, forms my answer for this problem.